What if a single ripple in spacetime could shatter everything we know about black holes? In 2019, LIGO and Virgo detected a gravitational wave signal so strange that physicists are still struggling to explain it without rewriting the laws of physics. This wasn't just another merger of two black holes. Buried in the data was a faint echo-like pattern that, if real, might reveal the long-sought boundary where general relativity breaks down and quantum reality takes over. The signal, named GW190521, came from the collision of two massive black holes, forming a new black hole about 142 times the mass of our Sun. That mass itself was startling because it falls squarely in the pair instability mass gap, a range where stellar explosions shouldn't leave behind black holes at all. But the real shock arrived when researchers reanalyzed the data using a different technique. They found tentative evidence of additional quiet pulses arriving milliseconds after the main merger chirp, a series of diminishing echoes that shouldn't exist if the final object was a classical black hole. According to general relativity, a black hole is a one-way door surrounded by a perfectly smooth event horizon. Once gravitational waves escape from the ring-down phase, the brief vibrating period after the mergering incoming signal should vanish forever. There's nothing to reflect a wave back. Yet the claimed echoes suggest a reflective surface, perhaps a microscopic Planck-scale structure just outside where the event horizon should be. That idea aligns with radical proposals like firewalls or fuzzballs, which emerge from string theory and attempt to solve the infamous black hole information paradox by replacing the horizon with a seething quantum membrane. Instead of a point of infinite density at the center, the entire black hole interior becomes a tangled ball of strings, capable of bouncing gravitational waves like a cosmic drum. Of course, this interpretation remains fiercely debated. The echo signal could be a statistical fluke noise from the detectors or a misinterpretation of the complex ringdown. Multiple independent analyses have failed to reproduce the echoes with high confidence, so the consensus is that GW190521 has not proven new physics yet. But the very fact that a gravitational wave observatory can even test such quantum gravity ideas marks a stunning shift. For decades, black hole echoes were a purely theoretical playground, and now LIGO has turned them into an experimental question. If you were analyzing this signal, would you bet that these echoes are real whispers from the quantum edge of space-time or just random noise fooling our best instruments? Let me know your answer in the comments. The LIGO signal, GW190521, remains an unresolved paradox, straddling the line between a record-breaking merger and a potential glitch that could uproot modern physics. As detectors grow more sensitive, we may soon catch a definitive echo that finally tells us what truly hides behind the curtain of the event horizon. Thanks for watching. Please subscribe to my YouTube channel for more interesting videos.